Hi everyone, so today we're going to be talking about one variable equation word problems. On these ones, they're just word problems that we are going to set up and solve, set up an equation and then solve that equation for x. So you should have your example paper in front of you. I am not going to write out each word problem, mostly because they're too long to write out and I don't want this video to be a massive one. So let's just start with the first example. In the first example, it says Susie has 6 times as many candy bars as Jimmy. Together they have 30 candy bars. How many candy bars does Susie have? So the way that I like to do these is most of the time they give you two things that are happening, or two people or two things that are happening, something like that. So in this case we have Susie and we have Jimmy. And then what I'm going to do, I know that Susie has 6 times as many candy bars as Jimmy. So if Jimmy has X candy bars, or X amount of candy bars, then Susie, because she has 6 times that amount, would have 6X candy bars. And we know together they have 30 candy bars. So the equation that we can write would be 6X for Susie plus X for Jimmy has to be equal to 30, because in total they have 30 candy bars. So from here, what we're going to do is now just solve for x. So we have 6x plus x gives me 7x, and that's equal to 30. And then to solve this for x, we would just divide both sides by 7. And we get x is equal to, this is not going to come out clean, which is interesting because there aren't, like, maybe somebody ate half a candy bar or something, but that's okay. The ones on your self-checks will come out clean. This gives me, we're going to just round it to 4.3. So x is 4.3. Now, x we talked about is Jimmy, right? But the question is asking for how many candy bars Susie has. So if Jimmy has 4.3 candy bars, then Susie must have 6 times 4.3 candy bars, which is, let's see. So we know that Susie is 6 times 4.3 candy bars. So she's got 25.8 candy bars. All right. So the hardest part about that, honestly, is being able to read the equation and then set it up, or set up the equation. The solving the equation you should have down, but a lot of these on your self-check will look incredibly similar to each other. So as long as you feel comfortable kind of working with these examples, you should be okay. So let's go through the next example. And the next example says a father is now 3 times as old as his son. 8 years ago, the father was 5 times as old as the son. How old is the father now? So right now, we know father, I'm going to make that F, is equal to 3 times his son. So I can say 3 times his son. 8 years ago, the father was 5 times his son. So father 8 years ago would be 5 times his son, but because it was 8 years ago, we have to say the son minus 8, because it was 8 years ago, or previous years. So this is a little bit different way to set it up than what we just did, but in these cases when you're talking about age, it's easiest if you can kind of set some, like, the two things equal to each other. Notice that you have the 2 fathers that are both equal to something. If I have 2 things that are equal to F, then I can actually set them equal to each other. So I can take those 2 things and say that 3S is equal to 5 times S minus 8. And then what I can do is solve that for S. And so to solve that for S, I'm going to distribute the 5. And I get 3S is equal to 5S minus 40. Then I want to get the s's on the same side, so I'm going to subtract 5s from each side. and I get negative 2s is equal to negative 40. Then I'm going to divide both sides by negative 2 because I want to get the s by itself. And I get s is equal to, sorry, that should be a negative 2. S is equal to 20. So what that tells me is that the son right now is 20 years old. So if the father is 3 times as old as his son, that means that the father, we're going to just use that top equation, this one right here, is equal to 3 times 20, which is equal to 60. So the father is 60 years old. So that's how you're going to do the age ones. Now, let's go through the third example. The third example says, a bus leaves the terminal and averages 40 kilometers per hour. 1 hour later, a second bus leaves the same terminal and averages 50 kilometers per hour. In how many hours will the second bus pass the first bus? So, in this case, when we're talking about distances and rates and stuff like that, we're going to use the formula distance is equal to rate times time. What I'm going to do is have a section for the first bus and a section for the second bus. So first bus, we know that it's going, the rate is 40 kilometers per hour. For the second bus, we know the rate is 50 kilometers per hour. We don't know let's think about this. So the distance we don't know. I'm going to make that a question mark for both of them. And then the time, we know the first bus had, let me think. We would do, the second bus had X hours, and then the first bus had X plus 1 hours. The reason why it's X plus 1 hours is because it had an extra hour. Like the second bus didn't leave until 1 hour later. So I know this is confusing right now, but I'm going to just plug all of that into this distance equals rate times time equation for both equations. So distance is question mark equals rate, which is 40, times time, which is X plus 1. Then for my second bus, I'm going to have distance, which is question mark again, equals rate, which is 50, times time, which is X. Now, the reason why we can actually put both of the distances as a question mark, like they're not different, is because we're looking for when they meet each other, or when they, it's asking for when the second bus passes the first bus, but basically that's at the same amount of distance, that they've traveled the same distance. So now we're going to treat it kind of like that second example. In that second example, because we had both of those equations equal to F right here, we set them equal to each other. In this case, because we have both of the equations set equal to a question mark, we can set them equal to each other. So I'm going to say 40 times X plus 1 equals 50X. And now I'm going to solve that equation. The way that I'm going to do that is by first distributing the 40. So I get 40X plus 40 equals 50X. Now I'm going to get the x's on the same side by subtracting 40x from each side. And I would get 40 equals 10x. Then I'm going to divide both sides by 10 just to get the x by itself. And I'd get 4 is equal to x. Now, what that tells me is that, okay, give me 1 second, but I can get back in. Sorry, guys. What that tells me is that the second bus, which was this one, is, second bus, which is this one, took 4 hours to catch up to the first bus. So my answer actually is that it's 4 hours. The first bus drove for 5 hours, but because the second bus was going faster, it only had to take 4 hours. Okay. Sorry about that small interruption. Let's go through the last example. So this last example says a coin collection amounting to $25 consists of nickels and dimes. There are 3 times as many nickels as dimes. How many nickels are there? So we're going to kind of set it up the same way that we had in the first one. So I'm going to talk about nickels and dimes. So we know that there are 3 times as many nickels as there are dimes. And so what that tells me is that if I have like D dimes, then I have 3D nickels because it's 3 times as many. So now, and the other thing I know is that nickels cost or amount to 5 cents and dimes amount to 10 cents. So that's the way that I'm going to write them. I also know that it totals $25. So what I can do is I can say that 0.05 times my nickels, but my nickels are 3D, right? Because that's kind of like 3D is equal to N, because I know it's 3 times the dimes, plus 0.10 times just regular D, because that's my dimes, is equal to the $25. So now what I'm going to do is simplify and solve that for D. So we do 0.05 times 3D, which gives me 0.15D plus 0.10D equals 25. Then I'm going to add those two things together because they're like terms because they both have D's. So I'd get 0.25D equals 25. And now what I'm going to do is divide each side by 0.25 to get the D by itself. And we would end up with D equals 100, sorry. Which means what that tells me is that there has to be 100 dimes. Now, if there are 100 dimes in this collection, that wasn't the question it asked. It asked for me my nickels, and I know nickels are 3D. So what that tells me is that I do 3 times 100 to find the amount of nickels, which means that there are 300 nickels. And that is my answer. So these word problems definitely are a little bit harder to set up, but I think that I gave you examples of all the different sections that you would have. Once you get them set up, they're actually pretty easy to solve. So good luck.